Okay, now it's on. Okay, and it is still streaming. I thought I pressed the button, but it didn't go. Okay. Okay, I'll move this out of your view, but I can still take a look at it. Oh, wait. Okay, all streams. Okay, do you want to exit? No. Okay, so now it's still streaming. There should be no interrupt to the streaming. All right, so look at this code here, and we have to say something about the precondition. So we'll say the precondition of line 1 is the following. We will assume the current m is less than n. Okay, that's an assumption. We will specify that m is greater than 0. We'll specify that k is greater than 0. We'll greater than or equal to. M is greater than or equal to 0. And the same thing applies to n. We'll specify n is also greater than or equal to 0. Okay. And we assume nothing about x. Is that okay? Yep.
So should we be able to understand like where you get this from, or are these just like parameters you're giving us?
That would be given to you in the question. So the precondition of the very first line of the block of code that you need to analyze is going to be just something that's given to you. In this case, there are specific reasons why these are the preconditions, but in general, you don't have to question why are these the precondition. You just have to say, okay, this is the assumption, and then we'll just go from there. Okay. All right. But even from the code itself, we can see that only m and x are changed. So anything that we say about k, anything that we say about n, is not going to change. Okay, you are expecting k is greater than or equal to 0, and n is greater than or equal to 0 to remain the same in the post condition of the entire thing, which is post 7. Is that making any sense? Because we are not touching those variables or constants. Okay, so if that is a precondition, what is the post condition of line 1? So I write it here, but we are really trying to answer the question. So you have to give me some reason of what you're planning to do with this particular post condition. So what is the first thing you need to look at in order to decide how to derive the post condition of line 1? Sorry? Whether it has an inverse or not. Okay? And that is because line 1 is what? It's an assignment statement. Okay, so when it's an assignment statement, then you analyze and you choose one of the two. Are we using the forget rule, or are we using the substitution rule? Okay? And the key to determine which one to use has to do with when you look at the right-hand side of line 1 as a function of the variable on the left-hand side, the question is it reversible? So in this case, we are now asking the following question. So now we are saying, does f of m equals to m plus k reversible? Or does it have an inverse? Does this have an inverse? So that's the question. Assuming k doesn't change, okay, does it have an inverse? Yes, it does have an inverse. Okay, so what would the inverse look like? M minus k, correct. Okay, very good. Now, because it does have an inverse, which rule should we use? Substitution. Okay, use substitution rule. So now we just apply the template. Whenever you apply the substitution rule, the post condition of a line is based on the precondition of the same line. Okay. But we have to specify what we are looking for and what we are replacing that with. What we are looking for would be the variable on the left-hand side, in this case m, and what we are replacing it with is the inverse function applied to the same variable. Is that okay? So instead of just doing this mechanically, which is important, we also want to remember why that is the case. Because f prime, which is the inverse function of f, is reversing the value of m after the assignment back to what it was before. Is that making any sense? Because line 1 is doing something to m, okay? It is applying a certain operation to m, m's value is changing. But because it is a reversible operation, because an inverse function does exist, when we apply the inverse function to the value of m after the assignment has already occurred, it reverses that back to the original value of m. Is that making any sense? So however we relate the original value of m to everything else can still be maintained as long as we say, oh, I know m has changed, okay, but if we apply these inverse operation so that we reverse the value of m back to what it was, then everything is still good. So that is the reason why the substitution rule has a template that looks like this. So that is also important to understand so that you're not just kind of blindly and mechanically applying these rules. So now we just expand what the precondition is. So we take this and, oops, Control Z, there we go. Okay, so we just expand what is pre1, and then m, and then f of f prime is m minus k. And the next step is really boring because it really is just going through the whole thing. Every time you see m, replace it with m minus k. And k itself is fine, and itself is fine. Is that okay? So that becomes post 1. And now we can talk about what is pre2. Pre2 is post 1. Why is that the case? It's an if statement right after the assignment statement. So as far as lines 1 and 2 are concerned, they are sequential. There's no branching, no jumping around between line 1 and line 2, okay? Because they are sequential. So now, we just have to try to figure out, okay, now we are in a conditional statement. Whenever you are trying to analyze a conditional statement, then there are two things to start with. The first one is, what is the precondition of the entire then branch? And the second question is, what is the precondition of the entire else branch? Because both of those can be derived by the precondition of the entire conditional statement and the condition itself of the conditional statement. Okay, does everybody understand what I just said? The precondition of the entire conditional statement is pre2. We know what pre2 is because it's the same thing as post 1. The condition of the conditional statement is m is greater than or equal to m is greater than or equal to n. Using those two, we can now derive the precondition of the entire then branch and the precondition of the entire else branch. So we'll go ahead and identify those. Okay, so we'll say the precondition of the then branch is pre3, and then the precondition of the else branch is pre6. So now the question is, well, what does pre3 look like? So just because of the structure of the code, we can say the following. Pre3 is pre2 and whatever the condition of the conditional statement is. In this case, it's m is greater than or equal to n. This has to do with the structure of a conditional statement and nothing else. So it doesn't really matter what pre2 really is. It doesn't matter what the condition is. You just have to use the condition in the second part of the conjunction. Yep?
Why would pre3 be pre2, not post2?
Because whatever is true right before line 2 still has to be true at this point. There are no assignment statements in between to change the value of any variables. Is that okay? There's no post 2 to speak of in this case. Because post 2 is confusing because we don't know which way the program is going to go. So we cannot say, oh, is post 2 the same thing as pre3 or is post 2 the same thing as pre6? Because we don't know which way it's going to go.
Wouldn't it be either?
Huh?
Wouldn't it be or?
No, it is not going to be or because it can only go in one single branch. Remember, the whole idea of pre and post condition is as if you are standing at a particular place on the trail and you're asking, if I am standing here, what has to be true? Okay? So if you're looking at a branch, okay, so should we draw a picture?
I'm just trying to wonder why
Okay, so if you think about post some line number, it is asking the question of what has to be true after this line, right? Where are you going to be after line 2?
Either pre-3 or pre-6.
Yes. So there's not a single post 2 that you can talk about.
Okay.
There's pre-3, that's one way to proceed with the execution of the code, and then there's pre-6, which is the other way of proceeding with this code here. But there's no post 2 because it has to go to one or the other direction.
So that sort of has to do with, like, if you were doing a backwards trace, then that's the logic that you would use. So at that point, there would be no, you haven't diverged yet.
If you're doing a backward trace and you're backtracking, then it is just a or. Okay, we'll handle a backtrace case next, okay? So let's not confuse it with a backtrace at this point. Yep.
So if I'm understanding, then pretty much the reason why there's not a post 2 is because you're going to cover both of those as pre-3 and pre-6 anyway, so there's no point in writing them now as an or when they're going to be covered anyway later.
Correct.
Yeah. Okay.
Another way to explain it is because syntactically, there's no meaning to post 2. Because syntactically, what is the relationship between line 2 and 3? How do they relate?
Line 3 is the true path of the
Correct.
the condition.
They're not sequential, right? So we can only talk about the post condition if it is sequential. In this case, because they're not sequential, we can't really talk about what is a post 2 because post 2, after line 2, we can proceed to 3 or 6. Yep.
So the Boolean doesn't get a post condition.
The Boolean does not get a post condition.
After line 2.
The Boolean, so you're referring to m is greater than or equal to n?
I think that's not Boolean statement.
The condition of the conditional statement. I forgot to write down the then, but that's just syntactic. Yep.
Does that apply to loops as well?
We're not going to analyze loops in the test, but in terms of the concepts, it is the same thing with loops. So if you have a while, we don't really talk about the post of the line that contains the while, because a while is the same thing. After the while line, are we continuing with another iteration, or are we getting out of the loop? So we have the same kind of situation of the line that we're going to go execute can be the line right after, or it can be the line after the end while. So the same kind of logic applies, but we're not going to have loops in this kind of code analysis. All right. So getting back to here, what about the precondition of line 6? It is about the same, because if I am about to execute line 6, it means the condition of the pre-2 condition still has to be true, because there's nothing between line 2 and line 6 that is changing the value of any of the variables. So, but then the condition of the conditional statement has to be false. M is greater than or equal to n has to be false if we are getting to line 6. Is that okay? Because that has to do with the structure of a conditional statement. Is that good so far? Okay. So now let's do the easy one. Okay. What about post 6? And to get all the points, it is important to expand what is pre-2. So we just look at pre-2, and pre-2 is the same as post 1, which is this mess here. So we say pre-6 is this mess. What about post 6 then?
Post 6 would be the same as pre-2.
Yep, because we are not doing a single thing, right? All right, so that means post 6 is the same thing as this mess here. But then we are forgetting one thing. Yep. So I would prefer to write it as m is less than n. Is that okay with you guys? Okay, all right. So that's the easier branch. The more difficult branch is this one. Pre-3 is this mess, and m is greater than or equal to n. Okay. Well, do we have any conflicts here? In other words, is there a problem that m minus k is less than n, but m itself is greater than or equal to n? Would that be conflicting? Nope, should not be conflicting at all, especially now that we know that k is greater than or equal to 0. If I tell you that k is less than 0, then we have a problem. Is that making any sense? If k is less than 0, then it cannot be the case. But because k is greater than or equal to 0, yeah, that can happen. All right, so now we need to look at post 3. And how do we derive post 3? So we look at line 3 itself, because we already know what is a precondition of line 3. So line 3 itself is just an assignment statement. And then when you look at the right-hand side, as if it is a function of the, when you look at the right-hand side, as if it is a function of the left-hand side, let's make it clear. So when we look at g of m of line 3 as m minus n, and look at n as a constant, do we have a way to reverse this? Yeah. Yep, okay, so g prime of m is going to be m plus n. Okay, very good. And as a result, because there's an inverse function, there's a way to go back, we can use the substitution rule. The substitution rule is really good because we are not losing anything as a result of applying the substitution rule. We're just changing things around, but we are not losing any knowledge of how variables and constants relate to each other. Is that okay? All right. So now we are going to say, okay, so post 3 is based on pre 3. It's the result of applying the substitution rule on pre 3. What am I looking for?
Conditions of m.
We're looking for m, and then we are replacing it with
M plus n.
Yep, g prime applied to m. So the next line is just an expansion of all of this stuff. And we are looking for m, replace it with m plus n. So now this is the tedious step. Look for all the m's. So we have m here. M plus n, the whole thing minus k is still less than n. And then same thing here. M plus, okay, one more parenthesis. M plus n minus k is greater than or equal to 0. And k is greater than or equal to 0. And n is greater than or equal to 0. And one more. M plus n is greater than or equal to n. Missing one paren here. Okay. That's it. That's the post condition of line 3. Can we clean this up a little bit? Absolutely. Do we need to? No, not really. Okay, if I want to, like clean this up, there are quite a few things we can clean up here. You can see how n is on both sides. So instead of saying m plus n minus k is less than n, we can just say m is less than k. Yep, you got it. Does it make sense? No. Okay, so we subtract it, exactly. We cancel the n on both sides. So we now have m minus k is less than 0. Then we add k to both sides, so it becomes m is less than k. Algebra, that's right. Okay, the next one is kind of the same deal. But there's no n in this case, but we can group all the constants together. So if I say n and k are constants, how do I relate m to just the constants, or an expression only involving the constants? Yep, you got it. These are just constraints, and then the last one is easy. How do we simplify m plus n is greater than or equal to n? Yep, m is greater than or equal to 0. So we can clean it up a little bit. Yep.
Why do we do the inverse on 25 and 11? You have that,
On 25,
yeah, 25, you have the G, or the prime GM equals M plus N, which is the inverse of GM equals M minus N. And then on 11, we do the inverse. Instead of M plus K, it's M minus K.
because the lines are different. Because on line 1, the right-hand side is M plus K. On line 3, the right-hand side is M minus N.
So why are we looking for the inverse, like, at all? I didn't know if I was confused about the inverse.
Because, okay, so the precondition of each of these lines is expressing how the variables relate to each other and the constants, okay? So we are saying, okay, before the changes to this particular variable, this is how they relate. This guy is greater than that guy is less than this guy, and so on. After the assignment statement, which changes the value of the variable, we want to say, well, do we know how the value of the new value of the variable relate to everything else? And the answer is, well, sort of, because we can reverse the operation. So we can reverse and find out what was the value of the variable before the assignment statement. So as long as we can reverse it back to those values, we can still maintain the relationship with the other variables and constants. So that's why we apply the inverse function when we do the substitution.
Thank you.
Yeah, I thought that part is kind of important because it's a conceptual kind of thing. And what we're doing here is kind of algebra and just mechanical stuff. Okay. All right, so line 3 is done. And then we look at line 4. So pre-4 is the same thing as post-3. This time we can do it because they are sequential. Yeah, go ahead.
There's no more reduction to be done on 30?
On 30,
K greater than or equal to 0, and M greater than or equal to 0 with M less than K?
I don't see how we can simplify without losing something. Because if you cross out any one of these conditions, you are expressing less than what we were expressing before. Okay. All right, so pre-4 is the same thing as post-3 because they are sequential. Because after line 3, we always end up on line 4. And that's the case where you can relate those two lines using just the equal. Is that making any sense? I cannot have a pre-3, I cannot have post-2 because it's not always the same after line 2. Sometimes after line 2, I go to line 3. Sometimes after line 2, I go to line 6. So that's why we cannot have a post-2. All right, so same analysis here. So this time we say h of x is x plus 1. Does it have an inverse? This one is easy. H prime of x, which is not the derivative like in the calculus class. In this case, I just use it as an inverse, is x minus 1. So once again, we use the substitution rule. So that means the post condition of line 4 is the result of applying substitution to the precondition of line 4. We look for occurrences of x and replace each occurrence with h prime, which is the inverse function of the right-hand side applied to x. So now we just have to expand everything. I'm going to use the cleaned up version because it just looks a little bit better. And this is the result of the application of the substitution rule because we didn't say anything about what we know about x. So after the substitution, there's actually nothing happening here. We still end up knowing nothing about x because we didn't relate x to anything on line 1, before line 1. Is that okay? Now, if we claimed, okay, before line 1, x equals to, pick another constant, j, okay? Then we can now say that x is 1 more than j. Is that okay? Or x minus 1 is j. But because we did not have any type of conditional comparison relating x to anything, so the substitution actually has nothing to do because there are no mentioning of x anywhere in the precondition. Is that okay? All right. All right, so I think we have all the pieces that we need to conclude this entire thing, because now the question is, what is the post condition of the entire thing, of the entire block of pseudocode, which is on line 7?
Post 3, post 4, wait, post 6 for sure.
Yeah, it's post 6 or post
3 and post 4.
Scroll back up to that code.
it's post 4. Yep. Yep. If I go back to the code,
Oh, yeah.
yeah, so there's post 4. So post 4, post 6 are the post conditions of each branch. Now, just for explanation, you don't have to do this in your answer. I just want to emphasize that post 4 is the post condition of the entire then branch. Post 6 is the post condition, cannot type, of the entire else branch. So when we are merging the two branches on line 7, then we say, the post condition of line 7 is just an OR, just a regular OR, not exclusive OR of the two. Is that okay? So if you want to expand this, it becomes, okay, whenever I do this, it's going to be a little bit messy. So we find what is post 6, which is this mess here. So we copy and paste it here. And then we look at what is post 4, which is this mess here. If you give me an answer like this, you will get full credit. But for me, I look at this and go like, that is awfully ugly. Can we simplify this? So to simplify this, we apply the usual stuff that you do in algebra, which is factoring. So you look at all the things that are common between line 45 and line 47. So let's quickly pick out things that are definitely in common between the two. Everything that we say about k is common because we haven't changed k at all. Everything that we say about n is also common because we haven't changed n at all. So we can factor out those two for sure. What else can we factor out? I don't think we can factor out any more than that. So we can factor out those two, but it's not required. Is that okay?
Is it just a matter of taking them out of the actual ending?
Well, it's just to make it look a little bit better.
And an end result that, if we just didn't have the k is greater than or equal to 0 and the n is greater than or equal to 0, then that would be fine as the final answer.
Well, if k is greater than or equal to 0, if these two are in the precondition, they have to be preserved.
So why are we factoring out if they're common?
Oh, I'm not factoring out entirely. I'm factoring out so that it doesn't have to be repeated on both sides of the disjunction.
So what would that look like?
What would that look like? Okay, it's going to look like this. So it's going to look like k is greater than or equal to 0, and n is greater than or equal to 0, and then this one is going to be the disjunction. So the rest of the disjunction, or the disjunction itself, is going to be whatever is left. So we take this, stash it here, and m is less than n. Yeah. Yeah, exactly. But since you asked me, so I'm going to answer the question. And m is greater than or equal to 0. So that's what happens when you factor it out. All right. Do we have any questions about the derivation of the post condition in this case? No questions? All right.
So all that explanation and everything that you've seen on past exams, if you've looked at some of the lectures and all that stuff, it needs to have all the explanations and all the.
Mm-hmm. Yep.
So this is the first exam that you've done that on for this class, right? So
In the other exam, what do you mean by it?
Exam.
You mean the other practice exam or practice one?
Well, other homeworks, let's just put it like that. On some of the other homeworks, there was no need for any of that.
No, if I had any homework involving pre and post conditions, I would expect that. Yep.
Okay, well, that's good to know.
So the bottom line is, if you're studying, how many things do you have to understand? Okay, there are a few things. Okay, there's the assignment statement, and you look at an assignment statement as this. Okay, whatever is on the left-hand side is a variable. Whatever is on the right-hand side is a function of whatever is on the left-hand side. You always look at it that way. Then the next question is, if you look at it like that, then the next question is, does f have an inverse? That is the question. Okay, if so, use the substitution rule. If not, use the forget rule. What does it mean when we say use the substitution rule? You basically say the post condition of whatever line you're in is the result of applying the substitution rule to the precondition of the same line. You look for all occurrences of the variable, the one on the left-hand side of the assignment, and replace every single occurrence with f prime, which is the inverse function of f, applied to the same variable. That is a template of applying the substitution rule. What about if we need to use the forget rule because there's no inverse function? Then the post condition of whatever line you're dealing with is the result of using the forget operation on the precondition. Everything that contains x needs to be removed. So every single condition that contains x has to be removed. But after the forget operation, you can also now claim that x does equal to f prime of x. So this is a very abstract general description, but this is how we deal with the pre and post conditions of an assignment statement. Okay, so that's template number one. Okay, template number two is has to do with sequential statements. Okay, so you have line n doing something, and then you have line n plus 1 doing something. As long as these two lines are not, it's not like one part is in a conditional statement or loop or something like that, something can change the flow of execution, then you can claim that the precondition of line n plus 1 is the same thing as the post condition of line n because they are sequential. Now, if line n is if blah, 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 then you cannot use this anymore. If line 58 is until in a loop, you cannot do this anymore. So this really only applies when line n and line n plus 1, okay, I'll put it the other way. This can only be used if line n plus 1 is always following line n. Is that okay? So if one is the end of a loop and the other one is the beginning of a conditional statement, well, guess what? It still works. Because the end of a loop, if line n is end while, and then line n plus 1 is if blah, 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 this still works because they're still sequential. So the bottom line is, okay, the bottom line, the bottom line is if line n plus 1 always follows line n, then we can link the post and pre conditions. Okay, the next one is the conditional statement, which has the form of if some kind of condition, then, and then we have the entire branch here. Okay, so we have the then branch, else branch, and if. So I have to give them line numbers. So instead of using actual line numbers, I'll just call this line M, okay? And then this is line M plus 1. It's always M plus 1 with the then branch. So that one I can use a particular line. This one I have no idea where it is. So I'm going to call this line N. But then the else branch is always on line N plus 1. The and if can be somewhere else. We'll call this line P. Is that okay? Does everybody understand why I choose to use 3 different letters, M, N, and P? It's because I do not know how long the then branch is, and I do not know how long the else branch is. So I kind of have to use a different letter to represent where it starts. So in this case, what you do is you say the precondition of line M plus 1 is going to be the same thing as the precondition of M, but in addition, we also know the condition C has to be true. The precondition of N plus 1 is going to be the same as the precondition of line M, but we also know C has to be false. Is that okay? Now, because I really don't know what is in the then branch, it can be a whole bunch of assignment statements, can be a loop, can be another conditional statement. Same thing applies to the else branch. I can't really tell you, a very mechanical way to derive the entire post condition of the then branch. But one thing I know is the post condition of line n minus 1 is the post condition of the entire then branch. Does that make sense? Because line n is the word else, so whatever line is right before the else is the last line of the then branch. So the post condition of that line is the post condition of the entire then branch. Is that okay? And for the same reason, post p minus 1 is the post condition of the entire else branch. So now the biggest question is, what is the post condition of the entire conditional statement? It's post n minus 1 or post p minus 1. Is that okay? I'm giving you the structure. This is more abstract because we are using variable names as line numbers, but at the same time, I'm giving you the very same mechanism. The only thing you have to remember to apply it to different situations. Yep?
Is the end of a conditional statement the only time that we would notice the or being used between post or post conditions?
Yes, not counting loops. Not counting loops, this is the only way to attach ors into conditions. But as you go through the code and you have more and more conditional statements, then you end up with more and more and more ors. Any other questions? And are there any questions about these templates? Because if I want to summarize the entire pre and post condition module, it will be condensed into this. Not counting the loop stuff, but the loop stuff is not in the scope of the test. Is that okay?
Not to ask for trouble, but why are we not getting loops on the exam?
Because to analyze loops, you have to find the loop invariant. And the loop invariant is not, there's no fixed procedure to find the loop invariant. The condition that stays true before, during, and after a loop, that's a little bit tricky to find. So that's why I'm excluding the analysis of loops from the exam.
Is there ever a class where we expect to do
Yeah, there'll be some classes like that,
that later on? Though?
in a 4-year university. Yeah, in a 4-year university, they might offer a class called like program verification, code verification, or something along that line. Those classes will have a much more formal treatment of these things. But as far as we are concerned, we just have to kind of deal with the simpler cases. Is that okay? All right. Any other questions about pre and post conditions? I think this is as condensed as I can make it. If there are no questions, let's go ahead and take a 5-minute break, and you guys can think of what you want me to go over in the next hour.
Whatever the hardest example is.
Well, we cannot know that because I haven't made up the exam yet.
Come on, you gotta have an idea what you're gonna
Oh, no. I wait till the last minute.
What's the
Okay, it's 48 right now, so we'll come back at 50. Let's make it 54. Coffee time. I like the idea of a suspender.
I don't.
You don't?
I hate it.
You hate it?
No, it's because it doesn't tighten around you. It holds it up.
Yeah, but that's
But
need held up.
if you tighten it too much,
Uh-huh.
it pulls it up past the play button and up to like here, and it looks really weird.
I see.
So I have to constantly fix it.
Okay.
It's nice.
What was it? I understand because you just got back.
start the recorder. And
template there. Would you mind just scrolling down for a second so I can just finish the last?
okay, sure, absolutely. All right, the recorder is still on. The mic is good. And there was a request to re-display the template, so I'm gonna let you guys copy the template. As you guys can continue to think about what is next. What do you want me to talk about next? Oops. We can look into, well, you guys have signed up for classes already, right? Yeah, okay. Okay, we can do that. So are we good here? Can I switch the projector screen to something else? Okay, all right. So we'll go back to the browser. And where did I put the final exam, the practice exam?
That's at the very bottom under effects.
Oh, okay. Okay. So we went through a few examples. Did we go through this one? Yeah, we did. Yep, we talked about this one. It finds the smallest. Let's see here. Okay, the magnification. Okay, so FM is a subroutine to find. We know it either finds the maximum or the minimum. Which one does it find? So how do you know which one? Oh, okay. My cable got caught here. So which does it find the maximum, the index of the maximum, or does it find the index of the minimum? Maximum? How do you know it finds the maximum? Can also be minimum index, right? The x can come from index. Yep.
It's checking if the next value is greater than the one that's currently stored.
Yep. So the key is line 8, okay? So you're absolutely right. So on line 8, it only triggers the execution of line 9 if a bracket mx is less than a bracket I, which means if I see something, a particular element in the array that has a value that is greater than what I'm tracking, I need to update the index that I'm tracking. So that means I'm trying to keep track of the index of the largest element, not the smallest, okay? So that's very good. And then we know what SP is doing. SP is what? What kind of subroutine is that? What does it do? We have seen that sequence of the swap subroutine, exactly. So it exchanges the column that X and Y are representing or referencing. So that's the job of the SP subroutine. So when you look at the main subroutine on line 23, what do you think it's doing? Actually, we haven't traced this particular algorithm. I don't remember doing that. But we'll analyze it first, and then we'll track it down, okay? The second exam of another one, but it does cover subroutines. Okay. Okay, so this is a good one to go over because we haven't gone over this one. So on line 26, what stands out on line 26? What makes it kind of like, ugh? Yep. It has two invokes, okay? So first of all, it has two invocations, and then one invocation is inside the index operator, inside the square brackets, okay? So you can see the outer invoke, which is SP. Yeah, it seems pretty cool. I mean, it's just the invocation. But when you look at what I use to specify y as a parameter, that looks kind of ugly. So I think this is a good one to look at. Okay, so we'll take a look. We'll actually trace this code and find out what the trace is going to look like, because it involves only concepts that we have already gone over in class. It doesn't have records. Okay. It only has subroutines, return values, arrays, and array indexing, okay? Passing by value and passing by reference and local variables. So it hits every single thing, all in the same question. Yep.
Will we have records and text and all that on the exam?
Well, we did cover records, so it will be in the exam. All right. So we'll take a look at this one. And let's trace it. So once again, it is a good idea to bring along extra sheets of paper if you think you might need it, and a ruler to help you line the columns. So make sure that you bring those items if you are going to need that. All right. So I will leave the code on the PDF. So let me scroll this all the way so I have more space for the trace. There we go. And then in the trace, we have the usual. We definitely have line number. And this one has multiple conditions to evaluate, so we definitely need the comments column. Do we have any global variables? Well, let's check. So if we look at main, we have references to B, but B is a local variable. If we look at subroutine SP, it only has references to X, Y, which are parameters, and T, which is a local variable. So it doesn't have any reference to global variables. And then last, we look at FM, and it has references to MX, which is a local variable. It has references to I, which is a local variable, and it has references to A, which is a parameter, and nothing else. So there are no references to global variables. Is that okay? So without global variables, this is all we need to get it started. The precondition, there's nothing to say because there are no global variables. There's nothing here to say anything about when it comes to the precondition. So now we continue the execution of the code to the first line that is outside of the definition of a subroutine, which is main. Invoke main. This is on line 28. So in the trace, we go to line 28. Now we invoke the subroutine SP. We have return. You can use return line number or return info. Either one is okay because it's just post in this case, so it doesn't really make that much of a difference. Main has one local variable, but that local variable is an array. But we know how big the array is, so we have B bracket 0, B bracket 1, B bracket 2, because it is an array of 3 elements. When we invoke the subroutine, it is uninitialized. So every single column corresponding to B needs to have a single question mark. So this is how we get into main. When we're in main, we get to line 25. So line 25 is not really a statement that we have talked about. It's just verbally saying that we initialize B with the leftmost 3 digits of a student ID. So mine is not going to be a whole lot of fun because it's 0, 0, 0. So we'll pick something that's a little bit more interesting. Most of you have 1 something, 1617, these days. So that's not going to be very interesting either because 1 is going to be the least number. Well, maybe we can find 170. Okay, 170. There we go. That makes it a little bit more interesting. On line 26 is the interesting one because you have to think about what you need to do to get the job done. Okay, so we'll take a look at line 26. We go like, can we invoke SP now? Okay, X, not a problem. We're using B bracket 0 to specify parameter X. We got that, okay? But the second argument of how we want to specify parameter Y, we have a problem because we don't know which element of B we want to use to specify Y because that is determined by invoking fm. So that means the first thing we need to do is to invoke fm. Can we invoke fm? Well, it looks like we can do it because fm only needs to know where b is. And b is just a local variable that we have in main, so it's not a problem. So that is what we can start with. So on line 26, what we're going to start with is invoke fm using b to specify a. Are we good so far with that? Okay. So getting to the trace, we now set up return info. This time you do not have a choice. You cannot use return line number in this case because we have to get back to line 26. So you have to basically say, okay, when we get back to line 26, what is left to do? Well, we still have the invocation of sp to deal with. B bracket 0 specifies x. We got that. And then whatever the return value of the invocation of fm is going to be is what we use. Oh, I take it back. It's inside the b bracket. So the b bracket, and then we put a question mark inside the brackets because the invocation of fm is inside the square brackets. We replace the invocation with a single question mark. Are there any questions about how the return info is set up in this case? Oh, you guys cannot see the rest. Right? Let me move that over here. Yep, that's better. But do we have any questions about how we set up the return info of line 26? No questions? And you can see basically we use exactly the same rule every time we have an invocation that returns a value. The entire invocation is replaced by a single question mark, which is the placeholder of the return value. Is that okay? All right. We got some additional stuff to set up, just one more, which is parameter A. Parameter A is passed by reference, which means now we need to think about, okay, what are we using to pass to parameter A? It's passed by reference, and we are using B, and B is an array of 3 integers. Whenever you have something that is passed by reference, when you describe the parameter, it is always going to be a reference to either a single column or multiple columns. In this case, it's going to be multiple columns because it is referring to an array, and that array is from column D to column F. Yep?
So on the test, say we have this and we're writing it by hand, should we put column letters?
Yes. So you have to designate column letters on top of the columns. Okay? So that's a good question because otherwise you can't make references. Yep. You can wait until you need it to label the columns. So this way, in case you miss a column or you need to shift things around, you don't prematurely and you have to relabel the columns. Okay. All right. So now that we have everything set up, we continue execution in the subroutine. So let's scroll to subroutine FM. Oh, we have one more thing. What is the one more thing two more things that we have to allocate for FM? We have the local variables. We got mx as a local variable and I also as a local variable. So I almost forgot those. There we go. So now we got everything initialized. Almost, because these need to be unknown from the beginning. You guys cannot see that part. I can make this smaller. Nope, you still cannot see. I can make column G wrap around to save some space. Format text wrap text. There we go. It's not resizing the vertical. There we go. Okay. All right. So time to get into the subroutine, starting on line 5. Line 5 says mx is initialized to 0. The next line initializes I to 1, So that's what we have from lines 5 and 6. On line 7, it is a condition. I is less than bar A bar is true, because bar A bar is 3. Then we get to line 8. The condition of A bracket mx is less than A bracket I. Is it true or not? So what is mx? Mx is 0, I is 1, and A is not an array itself. It is a reference to an array. So when we say A bracket mx or A bracket 0, it's actually referring to B bracket 0, which has a value of 1. A bracket I, which is actually referring to B bracket 1, has a value of 7. 1 is less than 7 is true. So we get into the conditional statement on line 9, which simply copies I to mx. So mx is now 1. Then we get out of the conditional statement. We get to line 11, which is just incrementing I. So I goes from 1 to 2. Then we go back to the beginning of the subroutine on line 7. And then I is less than bar A bar is still true. Then we get to line 8 again. And then we ask A bracket mx is less than A bracket I. What do you think? It's false, because A bracket 1 has a value of 7. A bracket 2 has a value of 0. 7 is less than 0 is false. So we don't have anything to do with the conditional statement. We go to line 11. We add 1 to I. I is now 3. We go back to line 7 again. I is less than bar A bar is now false, because bar A bar is 3. 3 is less than 3 is false. We get out of the loop. We get to the return statement on line 13. So the return statement says return mx. So we go to mx and go like, what is mx? It's 1. So return mx is just returning a value of 1. So now we go to the rightmost return info cell, which is column G, copy and paste it, and then change the question mark to 1. So in the test, instead of actually writing everything down, you can save your time by just crossing out the question mark and replace it with the value that we are returning, which is 1 in this case. Is that okay? All right. So now we proceed after the return statement onto line 14. Line 14 is end define sub, which means at this point we've got 2 things to do. One is take note of where we should be going back to, so that the line number column can tell us what else we need to do on that line. The second thing we have to do is to deallocate everything that we allocated for this particular invocation. So columns G to J are now deallocated. And I already mentioned this, but it doesn't hurt to mention again. In the test, instead of writing all the words and then crossing them out, you can just cross out like this. So I would understand that as deallocating the columns. So now we're back to line 26. When we get back to line 26, it now looks like this, which is basically just invoking the swap subroutine, using B bracket 0 to specify parameter x, using B bracket 1 to specify parameter y. So that means we're invoking SP. We're ready to do that invocation. And any type of invocation of a subroutine either requires a return line number or return info. In this case, you can use either. But if you decide to use return info, then you have to, okay, let me go back to the line of invocation here. So we are talking about line 26. If you want to use return info, I'll show you what you need to do if you choose to use return info. If you use return info, then you have to say, which line are we returning to? Well, we are returning to line 27. What else do we have to do on line 27? And define sub. So that is what you need to do if you use return info. But if you use return line number, it's easier. Because if you use return line number, we just have to say, oh, we're going back to line 27. So that's why, in this case, using return line number can save you time because you don't have to rewrite the entire line up here. Is that okay? Does everybody know when you cannot use return line number? And what would that be? when you have to get back to the same line. Okay? If the invocation is on a particular line, but there are other things you have to do to get back to that line, which goes back to there's a return value, then you have to use return info. So if a subroutine returns a value, then the invocation of that subroutine can only use return info and not return line number. Okay? Yep.
So in your exams and your homework, it's okay to mix return line number with return info?
Yeah.
Depending on how it needs to be used.
Yes, as long as each one is used correctly based on the context.
And if we put return info and don't include where it needs to come back, then it's wrong.
If you use return info, then you have to not only indicate where you're going back to, but what else you need to do on that line. So that's why return info specifies more, and that's why it's more general and useful. But at the same time, when you're in the exam, you do want to spend your time writing down, and define sub instead of just the line number.
Right.
So that's the trade-off. Okay, so we're invoking swap, which has 2 parameters and 1 local variables. So we got parameter x, parameter y, and the local variable t. So this is where it gets a little bit tricky, when you're allocating, columns, because the column that we are reallocating for y needs to be wider now. So parameter x, okay, let's deal with this one by one, okay? What do I use here as parameter x? Parameter x, we use b bracket 0 to specify x. So what would that be? Yep, exactly. Reference to one single column, column D. And what do you think y is going to be? Reference to column E. Yep. Is that okay? Because right here we are mixing the concept of array indexing, because b bracket 0 is array indexing. So we are combining that concept with passing by reference. It doesn't really matter, because if you know b bracket 0 is referring to a particular column, then the pass by reference parameter is just going to refer to that column. Is that okay? So the most important part is to make sure whatever you use to specify parameter x is either a single column or multiple columns. As long as it meets those requirements, it is okay. But in this case, to make it look better, I'm going to make this a little bit wider so they can't see it. Okay. And then t is a local variable, so it starts with an unknown value. And we can still follow the code here because that's the kind of shorter one or narrower. So on line 19, we store the value of x to t. What is x? X refers to column D. Column D has a value of 1. So we are storing 1 to t, so t is now updated to 1. What about line 20? Line 20 says we want to use y to update x. What is y? Y refers to column E. What is in column E? 7. So we use 7 to update x. X refers to column D. So column D is the one that will be updated to 7. So this is now 7. Is that okay? Are we good so far? Okay. And then we get to line 21. Line 21 wants to use t, which has a value of 1, to update y. Y is passed by reference, so do not update this cell, okay? If a parameter is passed by reference, you update the column that it refers to, not the parameter itself. So this one refers to column E, so we are going to update column E to be a 1. So that's what we'll do. And then we get to line 22, which is the end of the subroutine. So in this case, we just have to take a note of continuing on to line 27 when we're done. And also remember to deallocate the 4 columns that were used in this particular invocation. And now we are on line 27, which is the end of the main subroutine. So we have more things to deallocate and get back to post. So we look up the return info cell, we get to post, And then now we are deallocating 4 columns again. And those 4 columns are these 4. So we do a copy and paste and then do a strike through. And now we continue to post, which means we're all done. Do we have any questions about this particular trace? It involves multiple concepts that we have learned up to this point and kind of combining those, into one single program. Questions? No questions about this one? All right. If there are no questions about this one, we move on to the next sample program. So this one does have a record. So before we trace it, we'll take a look at what it does, at least in terms of just looking at the code, and then we'll go ahead and actually trace it. So we'll start with line 1 to line 4. That's the definition of a record type. So the definition of a record type does not use up any space, does not use up any columns, because it's really just saying, okay, this is a blank form, okay? If we have forms of this kind, it's going to look like this, but it's just a template. So lines 1 to 4 does not really do anything as far as, this is, it doesn't execute. On line 5, we have the start of the subroutine called SH, and we'll take a look at this particular subroutine and try to find out what it does. It has 3 parameters. It has parameter A, which is an array, and it is an array of something. It's passed by reference. We have parameter K and parameter I, so those are also specified by the caller. And then the subroutine has a single conditional statement, which is starting on line 10, ending on line 17. To try to figure out what V is. V is our local variable with a type of Boolean, so it's either true or false. And it is recursive. So the condition for the recursive case on line 10 is if I is less than bar A bar, then we go to line 11 to line 14, which is the recursive side. If I is not less than bar A bar, then we go to line 16, which is the else part. Okay, so we try to analyze the then branch first. So the then branch says, on line 11, it is invoking SH again, but this time the only change is I, parameter I gets I plus 1 compared to the current invocation. So you can see how the invocation will eventually end, because every time we call SH on line 11, the value of parameter I increases by 1. So eventually it will start with 0, because that's what main is going to do, and then 1, and then 2, and then eventually it will get to bar A bar. Then the subroutine will end. So that would, whatever invoke SH on line 11 is returning, we store that in local variable V, and then we ask the question, is V less than 0? That doesn't seem to make sense. No, that doesn't make sense, because V is a Boolean. We cannot ask whether a Boolean is less than 0 or not.
And line 16, is that what's on line 16?
V is negative 1.
Yeah, so it's a sort, right?
No, it's not a sort. So V should not be a Boolean. V is an integer. So it doesn't make sense that V is a Boolean. So cross out that Boolean if you have a local copy. Cross out that Boolean and make it an integer.
Is there a language where negative 1 equals false? Is there a programming language where negative 1 equals false?
No. I do not know of any programming language that equates negative 1 to false. There are many languages that would equate 0 to false and non-zero to true. So 1 is true, 7 is true, negative 6 is true, 1.5 is true. But not in this class. Okay, so in this class, we don't mix Boolean and integers. So that will also make the return type of the entire thing, an integer. So make that change first. Okay, local V is an integer. So we ask, if v is less than 0 and a bracket I dot k equals to k, then we do the other assignment, okay, on line 13. V gets a bracket I dot v, and if. Is that okay? So I is progressing, going from 0, 1, 2, and so on, until we get to the last one, where v is going to be a negative. If v is negative, the first part of the conjunction is going to be true, and then we're going to overwrite v with the value of something else. Is that okay? But do we know what to do when we execute this code? Okay. And then main is initialized like this. It has 2 digits. The question itself would tell you what to do with D1 and D2. So it says right here, D1 and D2 are the first, which is the leftmost, and the last, which is the rightmost digit of your student ID. And main is going to initialize B bracket. So B only has 2 elements, so this is not going to go too far. So B has 2 elements. The first element has D1 and D2 as the values of the members K and V. The second element has D1 plus 2 and D2 plus 7 as the value of the member of K and V. And this is just going to print out the invocation, or the return value of the invocation. Is that okay so far? Yeah? Okay. So let's go ahead and trace it. Well, it's really just a whole lot of stuff to see if you understand how records work and how to do recursive subroutines and stuff like that. All right, so let's give this one a try. We got line number, comments. And once again, we do not have any global variables, so the precondition really has nothing to say. We invoke main first on line 28. When we invoke main, we can use return line number to post. Okay, either return line number or return info cell is fine in this case. And then we have a whole bunch of columns to allocate. Because main has a local variable, a single one, which is B. But B, so this time I'm going to use a more structured way to look at B. So B has 2 elements. It has got B bracket 0 and B bracket 1. But the way I write this has to do with B bracket 0 has 2 members. The first member is, okay, I cannot remember the order here. The first member is K, and then the second member is V. And then B bracket 1 is the same thing. It has 2 members. The first member is K. The second member is V. So is this okay? I mean, B is referring to, oh, okay, you can't see the last one. Okay, let me do this part here. So when we refer to B, B itself is referring to all 4 columns, because that's the that is referring to the entire array. So this is what B is. When we refer to B bracket 0, we're referring to the first element of the array, which is basically these 2 columns. B bracket 1 refers to those 2 columns. B bracket 0 dot K, which is the member K of B bracket 0, is now doing a single column, because it is just an integer, which only uses up 1 single column. So are we okay so far with how we allocate columns D, E, F, and G just for the array B? Do we need to have the common B at the top?
Yeah, so it's B0 with K and V and B1 with K and V.
As long as line 5 is clear to me that you understand that B uses 4 columns, and the first 2 columns are for B bracket 0, and the second 2 columns are for B bracket 1, it's fine. Because what I'm looking for is that you understand that each element of B is a record, and each record has its members. So as long as that is clear to me in the use of the columns, it'll be fine. Is that okay? And those are all local variables, which means every single one starts with an unknown value. Is that okay? So now we proceed to line 22 of main. So what student ID do we want to use here? Well, we can use mine. Okay, so this is 0. And in line 23, that's going to be 00097. And then on line 24, I'm just scrolling down here. So on line 24, it is 0 plus 2, which is a 2. And then on line 25, it is D2 plus 7. So it's 7 plus 7, which is 14. Are we okay so far? Okay. So now we're done with all the initialization. We go to line 26. Line 26 is printing just the return value of invoking sh. So what we need is a return info. When we get back to line 26, we just have to print whatever the return value is. So the return info is surprisingly easy this time. But we have to set up the additional columns because we have parameters and local variables to deal with. So we deal with the parameters first. The parameters to pass is B is specifying A. So parameter A is now a reference to multiple columns because I'm using the entire array B to specify parameter A. So that means it is referring to columns D all the way to G. The next one is K. Oops. So parameter K is passed by value, and we are using D1 to specify that. D1 is 0 in this case. And then we have parameter I, which is also just going to be 0. And then we have local variable V, which starts with an unknown value. So that's how we set up all the columns when we invoke the subroutine. Are we okay so far? Oh, you cannot see the whole thing. Okay. There we go. Is that better? Okay, all right. So now we go into the subroutine. So the subroutine starts with a conditional statement on line, okay, this makes it kind of difficult to track. I'm gonna do this. Okay, all right, that looks okay. So on line 10, we have to evaluate the condition. Oh, okay. It just needs a little bit more space. There we go. I is less than bar A bar is true. So we go to line 11. Line 11 is recursive. So we have to set up all the columns again. We got return info, A, K, I, and local variable V. That's the easy one. I is the only one that's changed. So when you look at line 11, you can see how it is only using A to specify A, is using K to specify K, and then I plus 1 to specify I. So I is the only one that got changed, or incremented in this case. So I goes from 0 to 1. K is the same as before, which is 0. A is still the same as before, which is a reference to columns D to G. And then return info also needs to be changed, because when we are done with this invocation, what do we need to do? We need to go back to line 11 to finish the assignment. So we say we have to go back to line 11 And when we get back, V is going to get whatever the return value is going to be. So let me resize the columns. There you go. So is that good? Okay. So now that we have all the columns set up, we continue to at the beginning of the subroutine, because every time you invoke a subroutine, you start from the beginning. It doesn't matter whether it's recursive or not. So we start on line 10 again. I is less than bar A bar is still true. So we move on to line 11, and we're going to do about the same thing. So this time I'm just going to be super lazy and copy and paste all the cells and only change one, right? Because I is the only one that got changed. That's the only one that got incremented. So I goes from 1 to 2, and we'll there we go. And then we get back to line 10 again. So when we get to line 10 this time, the condition is going to be false, because the number of elements in A, which refers to B, which only has 2 elements, is 2, and I is 2 at this point. So now we go to line 16. V gets a value of -1, and V this time is referring to column V, which is coincidental. It just so happens, okay? And then after line 16, we get to line 18, which is a return statement. It's returning -1, which means whatever is the rightmost return info cell, we copy and paste it, change the question mark to -1, and we're done. So now we use the return info cell to tell us where to go back to. So we are going back to line 11, and then the 5 columns that we have allocated are now deallocated. Line 19, yep, I got it. So this is line 19. This is where we refer to the return info cell, and line 19 is where we deallocate all the columns. Oops. There we go. There we go. So are we good so far? Now we are back to line 11. But you have to remember, the columns are now, you have to move back to columns M to Q. So it's only going to store V, -1 or -1 to V. So V, which is column Q, is updated to -1. Then we move on to line 12. Line 12 evaluates a condition. V is less than 0. It is less than 0. Can we stop here? No. Well, but text said we can do short-circuited evaluation. Can we short-circuit? We cannot. Not in this case. Because in the conjunction, there are 2 chances to make it false. I missed the first chance, but maybe the second one will make it false. So we have to evaluate the second one. So the second one asks, okay, so this part takes a little bit more space to specify. We'll take a look at this one. So the second one is A bracket I dot K equals to K. All right, so let's slow down and find out what is it referring to. Okay, so we start with A, okay? A refers to columns D to G. So A bracket I refers to element I. Element I is 1 at this point. So it's referring to the first element of whatever A is referring to. But not only that, that element is expected to be of the something type, which has 2 members. And we're only referring to member K of that element. And we're comparing that to the second K. The second K is referring to the parameter K. So are we doing okay so far with how to read A bracket I dot K equals K? The 2 Ks are different. The first K is a member. The second K is a parameter. Okay. So now we look up. Okay, so we'll expand this a little bit. So we are looking at this thing here. It has a value of 2. And then when we get back to here, this K has a value of 0. So it is false. So you only need one of the conditions in the conjunction to be false. If one is false, then the entire thing is false. So on line 12, the whole thing is false, which means there's nothing else to do. So we do not execute line 13, and there's nothing to do inside this condition, inside the then branch of the outer conditional statement. We go all the way to return v, which is on line 18. So on line, not 118, on line 18, we return a value of whatever v is, which is -1. So what do? We locate the rightmost return info cell, copy and paste, change the question mark to -1. So that's going to be this guy. So copy and paste, change the question mark to -1, and we're done. We are not updating this guy to -1. We are not updating the other one to -1. We just leave it alone, okay? Because this is not the time to execute whatever is described in return info cell. We're just changing the question mark. Then we proceed to line 19. We got two things to do. One is to remember where we're going back to and what else we need to do. And then the second one is to deallocate the columns. So this time it's easier because I got these columns already. So we will just copy and paste them like that. Now we get back to line 11. But remember, change the context because this is now out. So now we get back to here. So the v that we're updating on line 11 refers to L here. So column L is now updated to a -1. Then we proceed to line 12. So when we get to line 12, we're asking, okay, is v less than 0? Yes. Does a bracket I dot k equal to k? Okay, well, let's see. What I are we talking about? I refers to column k. So we are referring to the first element that A is referring to, but we're not looking at the entire element. We're only looking at member k of the entire element. So now we expose what it's referring to, which is column D to G. And we can't see a single thing because it scrolled off the screen. Okay. So we are looking at which column? We're looking at column D, in fact. So column D has a value of 0, and k is 0 as well. 0 equals to 0, so the condition is true. So when we get back here, when we document this thing, we have to say this is true. Is that okay? V is less than 0 for sure, because V is -1. A bracket I is A bracket 0, which refers to the first element of B. The member k of the element has a value of 0. Parameter k also has a value of 0. So 0 equals to 0 is true, so we have true and true, which is also true. Okay, so now let me get back to the current context here. And it's a little bit hard to see because now it's above, right here. So now we have to go into the conditional statement on line 13, and we're going to update a bracket I dot v to v. So this v here is now updated. What is it updated to? A bracket 0 dot v, member v of the first element of the array that A is referring to. And what is that going to be? Let's look it up. 7. Okay? So now we're updating this to 7. And now we are done with line 13. After line 13, it is the end of the inner conditional statement. There's nothing else to do with the entire then branch of the outer conditional statement. So now we go all the way to line 18. So line 18 is going to return v. V is 7. So now once again, we have to locate the rightmost return info cell. The rightmost return info cell is column H now. Copy and paste it. Change the question mark to 7. And now we're done with line 18. Moving on to line 19. Line 19 has two things to do. One is to denote where we're going back to, which is line 26. And the second thing is to deallocate the 5 columns that we have used up here. So we just copy and paste this. Okay. Deallocate. So now we are on line 26. When you print 7, it doesn't really do anything except, you just say, okay, print 7 on the screen. When that is done, we go to line 27. Line 27 is the end of the main subroutine. So we got two things to do. We have to look up the rightmost return line number in this case. And that should be right here. So it is post. So that means the next line to execute is just post, which means we are done. But we also have to remember to deallocate everything here. So we just copy and paste this over here, go to format, do a strike through, and then we are done. Do we have any questions about this? It takes me a lot longer, on a small projector than it would take you on a sheet of paper. Because on a sheet of paper, you don't have to go back and forth, scroll. Are there any questions about this particular trace? No? Okay. And then we'll move on, right? We'll continue to move on and okay, so we'll take a look at this one. This one has got it looks really short. And it has a subroutine called xt. Of course, I cannot remember why I called it xt now. It has got 4 parameters, x, y, z, and n. If n is equals to 1, it prints xz on the screen. Otherwise, it is going to call itself. Does anyone recognize this? We actually talked about this algorithm.
Isn't that the one where you said that
Now I remember why it's called xt. Did I talk about the Tower of Hanoi in this class? No? Okay. The Tower of Hanoi is a fun problem to solve. So, so it takes, okay, in the question, it doesn't really ask you to identify what the algorithm is, so you don't have to know this is the Tower of Hanoi. What you need to do is to really just blindly track through the program, produce the trace, and you're good, okay? But if you want to know what is the Tower of Hanoi, okay, it is a classic problem in algorithm design, and we'll look it up, okay, Tower, because I want to show you, huh? Sorry?
the typewriter's birthday.
I think something related to the typewriter. Animation, you like animation?
I was just like, well, they came up with animation.
There's a video out there.
Yeah, I know. And why not? We'll watch it.
My brain likes animation.
So, okay, after this, I'll explain what it's doing. It has 4 disks in this one, so it's going to take a while. 2 disks is okay. 4 disks is, it's going to take a while. Okay, I'm going to rewind this and explain what the problem is, and then we'll take a look at the algorithm again. Okay, so this is, okay, wait, don't move. Okay, pause first, and then move it back to the beginning. There we go. Okay, the first disk is actually still moving in error. Let me see if I can rewind it all the way to the beginning. There we go. Okay. So the objective is to move all the disk from the first pole to the last pole. But there are restrictions that you need to play by. The rules are, 1, you can only move 1 disk at a time. Okay? The second rule is all the disks on top have to be smaller than the disk below. Okay, those are the 2 basic rules. You can only move 1 disk at a time, and you cannot put a bigger disk on a smaller disk. Other than that, you can do anything you want.
It sounds like something off IQ test.
It's kind of like an IQ test, okay? So now the question is, how do I figure that out? So using recursion, the idea is, well, I'm going to break this into subproblems, okay? Because that's what recursion does, is it look at the bigger problem and break it down into a smaller problem. So the smaller problem is, I'm going to assume somebody can do this, okay? It's an assumption. I'm going to assume somebody can move the top 4 disks from the first pole to the second pole, okay? I'm going to subcontract to somebody to do it. Assuming it can be done, then my job is easy, because I just move the last disk, which is the green one, all from the first pole to all the way to the last pole. Then you go like, but the job is not done. What about the other 4 disks that are now in the middle pole? I'm going to subcontract that again to somebody else and say that I would tell that person, move these 4 disks from the middle pole, utilizing the first pole, and end up on the last pole. Is that okay? So now if you are the subcontractor, to move the first 4 disks or the top 4 disks to the second pole, then what are you going to do? Well, you say, well, that seems kind of difficult. I'm going to subcontract again. Somebody is going to move the top 3 disks from the first pole to the last pole, utilizing the middle pole. When that is done, I will move the second largest disk from the first pole to the second pole. And then I'll subcontract somebody again to move the 3 smaller disks from the last pole back to the center pole. That's the whole idea. Okay, so let's take a look at the algorithm. And that's in the browser. There we go. Not this. Where did I put it? It lost track of the bookmark because it timed out. Okay, but that's okay, we got it. Okay, x is an integer to identify the from pole, the first pole. Y is an integer to identify the second pole, the middle pole. It is also called the through pole. And then z is just an integer to identify the last pole, which is the destination pole. Okay. N is identifying the number of disks that I'm supposed to move. Is that okay? When n equals to 1, it's easy, because I'm only responsible to move 1 disk, right? I can just move it. So that's why I'm printing xz, which means I'm moving a single disk from pole x to post z, and I'm done. Is that okay? So the recursion is what happens when n does not equal to 1, when I'm asked to move more than 1 disks. Okay? That's when I need a subcontractor, or 2 subcontractors actually. The first subcontractor is going to move n minus 1 disks. So the last disk is my responsibility. But every single disk on top of that one, I'm going to ask a subcontractor to do it. So when you look at how I pass the parameters to the subcontractor, it's different from my parameters. So it is going to move from disk, from pole, but the middle pole, which is the through or the via pole, is going to be my destination. So I'm telling the subcontractor, you can borrow that pole if you need to move n minus 1 disks from the from pole of my perspective to the destination to the through pole from my perspective. Is that okay? Okay, let me draw a picture here. I'm just getting a little bit lazy here. So let's say this is my problem. I have 4 disks to move to here. This is my destination. So I'm going to have a subcontractor do it, to do some job for me. So the subcontractor, which I'm going to use a different color to identify, will basically finish his job or her job in this state. Okay. So this is what the problem that I'm given with. The subcontractor will leave the largest disk to me, but the subcontractor will move the top 3 disks over here, but using the last pole as a temporary pole. So this is the problem that I'm given with. This is what the subcontractor will complete for me, the first subcontractor. So now my job is easy, right? Because I only got 1 disk left. So from here, I will personally move the last disk, the largest one, from the from pole to the to pole, which is here. Then I'll have a second contractor. Okay, these 3 are still here, by the way. So now I have another subcontractor to say, okay, how about you move these 3 disks through this particular pole to this particular pole here. So now the last state of the entire thing is going to be this, this, and then now we have all 4 disks over here. Is that okay? What about, so now the subcontractor, which is supposed to go from here to here, is now thinking, how am I going to get that job done? So that subcontractor is going to look at this and go like, all right, I'm going to hire another subcontractor to move these 2 from here to here. Actually, from here back to here. Then I can move, the subcontractor can then move this one from here to here. Let's see. No. So the subcontractor needs to go from here to here. So so from that subcontractor's perspective, it wants to hire another subcontractor to move these 2 over here, and then the subcontractor will move this one to here, and then the subcontractor will move those 2 from here back to here. Is that okay? Okay. It is confusing. That's why we have the video. So. Okay, so we'll watch this thing. It only takes a minute. And we got a minute. And we're done. And all of that, okay, all of that is accomplished by the algorithm that we just described, except in order to regenerate what you just saw on YouTube, we pass 4 to n. 5, actually, there were 5 disks, right? Yeah. So we pass 5 to n. Can anyone guess how many moves there were in the case of there are 5 disks? Did anyone count? Should we play again so we can count the number of moves? Okay, so who wants to guess how many times it moved? Okay, think about okay, what if there's only 1 disk to move? How many moves do I need? 1, okay? What if I have 2 disks? Then I need 3 moves, right? What if I have 3 disks? How many moves do you think I need? No. 7, exactly. So I think you're starting to figure out the pattern. If we got 1 disk, it takes 1 move. If we have 2 disks, it takes 3 moves. if we have 3 disks, it takes 7 moves. So what do you think, what is the relationship? Close. Huh? Close. Is 2 to the power of n minus 1. N being the number of disks. So in the video, there were 5 disks. So there were 31 moves involved in the whole process. And since it took about a minute, so that means the animation of moving 1 disk takes about 2 seconds or so. Do you want to time it? No. But that's the idea. But that's all done using a simplistic algorithm like this. That is it. The algorithm itself is very simple, and it's recursive. And it is also difficult to express without recursion. Okay, so we got 4 minutes left. I'm not going to trace the whole thing, but I will do one thing. So we'll look up the Tau of Hanoi again. And, oh, cool. Not related. Okay, but I do want to explain what is the origin of the Tau of Hanoi problem. So, huh? Okay, solution origins, there we go. So the puzzle was invented by the French mathematician Edward Lucas. You cannot see it? Oh, there you go, you can see it. Oh, here's another one. It's a story about an Indian temple in Kashi Vishwanath, okay, which contains a large room with 3 time-worn posts in it. So there's a reason why it's time-worn. Surrounded by 64 golden discs. 64. Then you might think, this is not too bad. It only takes 1 minute for the animation to deal with 5. So how bad can 64 be, right? Well, it's unfortunately it is to the power of the number of disks. So we are looking at 2 to the power of 64 minus 1. That's the number of moves of the disks, okay? So acting out the command of an ancient prophecy have been moving these disks in accordance with the immutable rules of Brahma since that time. The puzzle is therefore known as the Tower of Brahma puzzle. According to the legend, when the last move of the puzzle is completed, the world will end. Okay, so let's figure out how long do we have before the world ends. Oh, they figured it out? But I want to show you how to do it, right? I mean, just if you just quote the answer, it's not fun. Okay. So plus, okay, so we can do this, right? So we are looking at 2 to the power of 64, 64 minus 1. Okay, that's the number of moves that it takes, okay? And let's assume that it only takes 2 seconds to move 1 disk, just like in the animation, right? So we say, what is 2 times this number? This is the number of seconds that we're dealing with. So now we want to equate that to days and so on. So we'll say, what about this number divided by 3600? That's an hour. What about this number divided by 24? That's, come on, divide. This number divided by 24, that's the number of days. And then we take this number and divide it by 365.25, okay, approximately, which is a year. And then we take this number and divide it by 1,000, which is a millennium. So it will take us this many millenniums to complete. So because this is already in number of years, right? So if you just look at this year, we are talking about 1,169 billions of years. The sun is going to expand and engulf the earth in a big, huge fireball in approximately, 4 billion years or so? Yeah. So we don't have to worry about that prophecy. Yeah, even if that prophecy was predicted like 6,000 years ago, compared to today, we still don't have to worry about that at all. We got other things to worry about first.
Do they have a picture of it?
Huh?
Of the one that supposedly started it all?
I don't know.
It's only been seen by men with no eyes.
It's supposedly the legend.
According to legend, exactly. So they have an algorithm that looks kind of like the one that we have, except it's a little bit different. So anyway, I don't think there's a picture of the actual item, but you can kind of imagine it doesn't look very complicated. You just have 3 poles.
Only 64.
It is only, yeah, that's the whole thing. There are only 64 discs, and you look at it and go like, well, it looks manageable. No. All right. Well, I'll see you guys on Wednesday, same time, but it's going to be the final exam. Okay, so don't forget, the next time we meet is going to be the final exam. So rest well before the test.